Hello everyone, this is me Abra Social Media Wala with another live guest. Her name is Mark Nover. Hello sir, how are you?
Oh, I'm doing well.
Okay. Sir, first of all, can you please introduce yourself?
Um, my name is Mark Novak, and I've been in IT for about 40 years. I've worked on mainframe processing from computer security to DBA, also worked in applications programming in various industries from manufacturing to pharmaceuticals to telecom type industries. And it's been a pretty long adventure within the world of within my world.
Okay sir, thank you so much. So my first question is, how would you define a mainframe platform and in what ways does it differ from mid-range or distribution systems?
Mainframe processes are different in that mainframes are more or less an integrated system of several computers that are working in cooperation. They are better at handling things like bandwidth. They are better at handling things like back-end technologies like DB2 or Oracle, because what happens is that the disk drives have dedicated computers on them. The interface has a dedicated computer. The communication has dedicated computers. So everything tends to integrate a little bit better. If you want to work with processes that need an awful lot of bandwidth, then you'll work with a mainframe. Now, in terms of sheer processing power, a mid-range system might bill itself as more powerful in the processing, but if that processing is also handling the computer storage and the disk drives and other parts of the computer, then it's taking away some of that power. So mainframes are integrated. They use a little bit different of an operating system. Mainframes use what is often referred to as MVS, ZOS operating systems, and those operating systems can allow a simulation of a mid-range system to run as a client or a sub-entry underneath the mainframe. So you could be on a mid-range system, but really be working on a mainframe. So it's a bigger computer. They date back to the 50s and into the 60s, but the technology has scaled, and a lot of processing is still being done on mainframes, particularly in the banking industry, telecommunications industry.
Okay, thank you so much. So my second question is, what are the primary business advantage of adopting a mainframe technology in large organizations?
Mainframe technology has the advantage of being able to be scalable and also being able to be leased out from another company. So if you have a mainframe, you don't necessarily have to have the mainframe on your site. There are companies that specialize in managing that particular mainframe for you at a remote location. So you can have workers that are across the country, and I realize that it's also true for the cloud. You can have workers across the country. If there are technical issues with that particular mainframe, then they'll have a group that will deal with those particular technical issues. Then you get the mainframe bandwidth advantage, you get the communication advantage. A mainframe can handle an awful lot more messaging and an awful lot more transactions, and it is easier to scale. Mainframes use about 10% of the power that you would see in cloud processing because of the way things are configured. Instead of thousands of smaller computers, you have fewer bigger machines. So you don't use as much energy when you are attached to a mainframe. And the mainframes are more secure because the mainframes are about 10% higher level of computer security as a mid-range system, as it is not as easy to hack into them. And then once you're in them, the software is much more difficult to, the software is much more advanced in compartmentalizing exactly where you can go.
Okay, so my next question, which sectors continue to rely heavily on mainframe and what are the key reasons for this reliance?
The sectors that tend to rely on mainframes the most are the banking sector, the financial sector, the telecommunications sector, and an awful lot of manufacturing areas. And the reason that a lot of companies are still using mainframes is because, quite frankly, they started using mainframes back in the 50s and 60s, and that technology has scaled real well. Behind an awful lot of transactions that you see at banking companies is an awful lot of old computer code. It might be layered beneath Java. It might be layered again beneath some mid-range interface, but there's a lot of code that is still doing the heavy lifting. We're handling database queries, for handling file transfers, for reading files, for processing data. Because these old processes, there was never any real reason to rewrite them, and that they're working their functions just fine. There's fewer moving parts, and it is easier to keep those processes running within the mainframe environment and scheduling them within the mainframe environment. It's a known quantity. So you'll see it in financial sectors, you'll see it in manufacturing sectors, and you'll see it in the telecom sectors.
Okay, thank you so much. So my next question is, can you explain the fundamental components of mainframe Ethernet?
Okay, mainframe architecture is a little bit interesting. You'll basically have computers that are specialized in doing the database processing, computers that are specialized in doing the file processing, computers that are specialized in doing the interface. You'll have a central processing unit. It will be in MIPS, and it would seem like it's a little bit slower than what you would see in a PC's processor, but those MIPS are all dedicated to processing. So what happens is that these computers, they all cooperate, and they look like one big system. They'll be separated out into different mainframes, but they may all be running under the same box, under what they call an LPAR. So you can have an LPAR, and the LPAR can look like a total computer in which you have your interface, you have the processing, you have the running, you can watch these particular processes. Now, your interface is going to be driven by a computer that specializes in interfaces that might have been a mainframe in the past. I remember back in the 80s, when I was learning how to process on the mainframe, that there was a controller device that someone showed me, and he said, this controller, which is handling the terminals, it has the architecture of the old IBM 360 computer, that they had retired an old mainframe, and then they brought it up to specialize in supporting the new mainframe in its process. So it's really a family of machines that is working. Each disk drive is basically a computer. The central processing system is basically a computer. Database interfacing is basically a computer, but it all looks to the individual like it is one computer. Even if you're programming in a machine language or assembly language, it might look like a machine, but it's a virtual machine to you.
Okay, so my next question is, what is on L-bar logical partition, and how does it contribute to system flexibility and resource management?
An LPAR is basically what used to be a whole mainframe. That back in the 60s, there was a lot of discussion about, we need to be able to run machines by themselves and not have to worry about whether or not there were other people on that particular machine doing other things. And initially what you would have is someone like in the manufacturing area, and they said, well, part of our processing is classified, and we want to be able to run it on this machine, but we don't want someone else logging on to this and then possibly being able to hack into that part of the machine. So what they would say is that they said, oh, okay, it used to be that you would have whole mainframes that were dedicated to the secure part or the unsecure part, or you'd have different companies that would be running the machine, running from the same mainframe. But what they basically said was that we're going to set up a virtual machine, and this virtual machine is going to look like the whole machine. So there'll be another LPAR, but the only way you can ever get to that LPAR is if it was defined to your LPAR, and that we had a defined communications channel between the two. So one process could run to the other, but it could not access They could only access certain files from that other LPAR. So what you see in an LPAR is you're seeing a virtual machine, virtual meaning not actual. It's running on the same machine, but it is as if it is a totally independent machine, a physically separated box running within the same CPU environment. I hope that sounds clear. It's a virtual is a term that basically means not actual, and that's basically the best way to put it. But it's functionally actual, functionally real, functionally an independent machine.
Okay, so my next question is, what is the core feature of IBM's and OS, and how do they support enterprise computing?
IBM ZOS processing was the newest architecture that we had. And what it allowed was is that it allowed people to rent as much machine as they needed at the time. So what would happen is that this was before cloud computing, and it was a concept that went into cloud computing. So IBM ZOS, you would have this layer, and underneath this layer, you could have an MVS machine running over here, which would be the classic mainframe technology and architecture. But then IBM could say, oh, you need to run a Unix platform to do communication because certain things run better under Unix. On software is already written configured under Unix. Oh, so we will produce a virtual machine that will be a Unix platform. It'll run in the same mainframe and it'll run in this particular platform. Now, there might be other machines or other flavors of processes, and they can run within that mainframe as if, so you could be on a Unix box and it could look perfectly like a Unix box, but it's running underneath that mainframe platform. The advantage that you also have is that, let's say someone says, oh my gosh, we don't have enough mainframe, we need more bandwidth. Well, there are companies out there which run these mainframes as virtual instances, and they said, okay, you need more mainframe from us, I'll write a check and we will give you more processing power. You can do that in the short term, which is now common in cloud, in which you say, for a little while, you're going to have 10 times more machine than you had before. So they would take that ZOS platforms and they would scale up and they would say, this platform now has more energy, more CPU MIPS and more resource, for this next 12 hours. So you can do that and you can make this LPAR bigger and then you can scale it back down. And within the ZOS platform, that can be done dynamically. Now, a lot of companies don't want to do that because paying for the short-term processing is more expensive than leasing it over the long term. But at least you have that option and you're not tied.
Okay, so my next question is, difference between JES2 and JES3. In which scenarios would each be preferred?
Okay, that's one of the weird things about this process is that JES 2 and JES 3 are two different types of areas in which you are running processes under and submitting batch processes. And the irony is that JES 3 was written after JES 2, but a lot of places prefer the JES 2 operating system. In terms of the specifics, I don't know all the specifics. All I know is that in terms of between the two of them, that there are sites which have went to JES 3 for various reasons, and they decided to go back to JES 2. I think that what happened was that JES 3 had some features that were in the short run that were better, but then when the ZOS platform was introduced, it became irrelevant, and it was better and easier to manage processes within the JES 2 batch running environment as opposed to the JES 3, because the JES 3 had features, and I'm not sure exactly what the specifics, but those features were no longer needed once you had the ZOS operating system running on top, in which you could manage things in a different way, and the JES 3's advantages had become irrelevant. So that's about all I can say about those.
Okay, so thank you. So my next question is, how does TSO time sharing option enhance user interactions for mainframe?
Okay, TSO is basically the command level interface. Now, TSO, you can still run TSO commands, and there's a lot of TSO commands that are being run. You can run them in a C